Hi, do you know that? Long, long ago, the population was believed to grow without bound, which follows the equation of exponential growth. Just like these bears are mushrooming in a short time. However, Adolphe Coutelet, a Belgian mathematician, was well aware that exponential growth must result in impossible values of population. So there must be something related to the logistic model. First, we'll look at logistic growth. In the 1830s, Coutelet's pupil, Pierre van Coist-Verhulst, also a Belgian mathematician, was inspired by him to work on the differential form of the logistic growth equation and studied it in relation to population growth. In Verhulst's model, dp over dt represents the rate that the population increases or decreases and is proportional to the population at time t. R represents the constant growth rate when p is small relative to k. P is the population as a function of the time t, and k represents the limiting value or the carrying capacity. Here is the most common form of logistic equation. The curve concaves up on minus infinity to a and concaves down on a to infinity. The inflection point a, k over 2, is where the graph changed its concavity. Nowadays, the logistic equation inspired many works and is being used in many different fields. In particular, population estimation using the logistic model has been widely used in various studies thanks to its accuracy and reliability. Let's see how the model can be applied in the context of Vietnam. Overall, we'll apply the logistic model to estimate Vietnam's population in the period of 2019 to 2024 and predict its population in 2059 and 2109. The data for this case is taken from the General Statistics Office of Vietnam and the United Nations Population Fund. After integrating the logistic differential equation, we have the solution as follows. Therefore, we can apply the model for estimating Vietnam's population in the future. This is the way logistic growth models can be used in real-life scenarios. The results appear quite close to the actual data. However, this model is limited by the fact that it relies only on the growth rate R, which is the birth rate minus the death rate. We can simply understand that it assumes that the growth rate stays constant. From the shortage in the logistic model, many attempts to address it have resulted in the development of other logistic models, such as the logistic regression model. Logistic regression is used to model the relationship between independent variables and categorical dependent variables. The logistic function has been modified for the use of regression. The exponent z now becomes an equation of all independent variables x1, x2, x3 to xn. Hence, we'll have the equation for logistic regression. Logistic regression is used for classification problems. In other words, it is used to classify the outcome into different categories. In practice, we need to predict the probability of many natural, economics, and social phenomena. To predict such events, we will need to use one type of logistic regression, which is binary logistic regression. To predict such events, we will need to use one type of logistic regression, which is binary logistic regression. The dependent variables of binary regression have two expressions, 0 and 1. A result less than 0.5 gives an answer of no, while a result equal to or greater than 0.5 means yes. Will a few studying hours lead to a failure in the test? Or can sleeping much degrade the student's performance? Who knows? Here, a binary logistic regression model will make predictions about whether a student will pass their examination. By displaying the result on a graph, it is evident that the logistic regression's predicted values fit into an S-shaped curve of a typical logistic model. The logistic model has been through a lengthy history and still now an applicable method in many fields, especially in population estimation and binary regression. So, The logistic growth model is such a powerful mathematical tool, isn't it? And now it's time for